Hello, welcome back to Cinderella Math. Today I'm doing a pre-calc lesson. This could perhaps be advanced algebra 2 as well for graphing rational functions. This is not trig. Anyway, it says pre-calc slash trig. No trig on this. It's just graphing rational functions. I'm going to cheat a little bit and like graph them in Desmos first and then graph them by hand and prove, the Desmos graph. All right. So I'm going to just go ahead and pop over to Desmos. I have 4 to do, but these do take a while. Go ahead, grab pen, paper, graph paper, calculator, all that good stuff. So our first one, the function it's a fraction because we're doing with the rationals. It's x squared plus 4x plus 5 over x plus 5. Oh, this one's supposed to be minus 5. Sorry. Minus 5. There we go. Nope, that's not right either. Sorry. If I could get my signs right, that would help a lot. Plus 4x minus 5. There we go. So that just looks like a line, but it is, but it's not. So that's our answer here. All right. So that is what we need to figure out, and we have to give all the information: y-intercepts, x-intercepts, horizontal asymptotes, vertical asymptotes, all that good stuff. So I'm actually going to cover up the answer, and let's get that same exact answer by hand. All right. Before you factor, I would recommend getting the y-intercept. So that's where we plug in 0. So let's come over to our function, plug in 0. So that'd be 0 squared plus 4 times 0 minus 5 all over 0 plus 5. Well, the bottom's, of course, just 5. This is 0, this is 0. So it's 0 plus 0 minus 5. So negative 5, which is negative 1. So there's our y-intercept. Okay, the other thing I recommend we do before factoring is our horizontal asymptote. Okay, that's where you compare the power of the top, so the degree of the top. So the top is 2, and I call that pigs. I'll have to do another video on that, but just go with me for now. And then compare the degree of that on the bottom. So that's an invisible 1, and I call that queens. So this is 1 queen. Boop. If your pigs or your top is bigger than your queens or the bottom, there is no horizontal asymptote. So you can just put none beside your horizontal asymptote. I'm going to call that HA for short just to save some time. Okay? Sometimes when there's exactly one more pig than queen, you will get a slant asymptote, but not in this one. And you're going to see why here in a second, though this will not have a slant asymptote. All right, so if you do have a slant asymptote spot, just go ahead and put none. Let's factor. So take that function and let's factor. The bottom, of course, is going to be fine. And the top, factor this trinomial however you've been taught to factor. I do the magic X method. That's going to be negative 5 and 4. We need to multiply here, add here. What if you have 5, spend 1? Yes, that would multiply correct. That would add correct. So this will be x plus 5, x minus 1. Does anything cancel? Yes, the x plus 5 knocks out. That will give us a whole. So when you factor and something cancels, that will lead to a hole in the graph. How do you find the hole? You take what cancels and you set him to 0. So we're doing x plus 5 equals 0. Move this over, x equals negative 5. That is the x of the hole. And now to get the y value of the hole, plug that back into the scratched out version of the function. So our new function is now just x minus 1. Plug in negative 5. Negative 5 minus 1 is negative 6. That is the y value of the hole. Okay? So now all you have to look at now is the scratched out version. So our function is x minus 1 over technically 1, but we don't even need that anymore. So there is no bottom. This is our function. We only get vertical asymptotes when there's a bottom. So we are going to say vertical asymptote, none. And final thing we can probably do from this is the x-intercept. X-intercept is the top, which x minus 1 was the top, set to 0. Move that over, so x is 1. That's our x-intercept. Okay, now let's take all that info and graph it. I'm going to just cover some stuff up. There we go. And by the way, look at the function, the pink box. That is a line, right? That is nothing but a line. We could rewrite this as y equals x minus 1. So that is in the form y equals mx plus b. We just have a line. That is literally what this is here. Look at the y-intercept. So -1, check. Look at the x-intercept, 1, check. Let's put the whole, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, whole. And then this is our line. What's the slope? 1 over 1. So from that kiss, which is -1, up 1 over 1, up 1 over 1, up 1 over 1, or down 1 over 1, down 1 over 1. There it is. Okay. Now, after we get the graph one, let's talk about domain. That would be all x values in the whole world except for this whole. So remember the whole was at -5, -6. So we're going to skip this in the domain, that x. So it's going to be left forever until you get to -5 and union symbol. Remember that's just a fancy math term for and. -5 to forever. Let's talk range. It goes down forever, it goes up forever, it just doesn't hit the y value of the whole. So down forever, hit the y value of the whole, stop, and -6 to forever. So basically we're just skipping the whole. All right, and I think one more thing we could talk about here is end behavior. Remember, make sure you always look both directions. I like to draw a little guy. You can just do this like in your head and turn him to the right. He would go up. So as x goes to the right, the function goes up. And then take another little guy and walk him to the left. That would go down. So as x goes to the left, the function goes down. All right, I think that's all the info on that one. Pause me if you're still writing. Let's look at the Desmos to see if we got it correct. So there's the Desmos. There is the Y. Yep. There's the X. Yep. Does it look like a straight line? Yep. And let's check the whole. So if you kind of just go, let's see, there it is, -5, comma, undefined. Yes, indeedy. It's good. That's it. No asymptotes. We're good to go. Next problem. Let's see. Here is the next problem. Again, I'm going to graph it first. It's x cubed minus 1 over x squared minus 9. Ooh, definitely harder. You can just kind of see from that graph there that this one's a bit of a nightmare, but we got this. All right. Okie dokie. So again, let's start with the y-intercept. We do this before factoring. Plug in 0. So that would be 0 cubed minus 1 over 0 squared minus 9. So that's -1 over -9, which is positive 1/9. Okay. And then the other thing we want to do before factoring is our horizontal asymptote with our pigs and queens. This has 3 pigs. That's the degree of the top. And 2 queens. That's the degree of the bottom. When the pigs are in charge, there's no rule in the land, so there is no horizontal asymptote. Now this time, there will be a slant asymptote. Sometimes teachers call this oblique asymptote. Same difference. We're going to do long division to figure that out. So this is x cubed, no x squares, no x's, minus 1, divide x squared minus 9. We do need to put in those zeros. I know it's annoying. How many x squared times what would be x cubed? You only look at the first things. X squared times x would be x cubed. Distribute that. That's x cubed. Distribute that. That would be negative 9x. Make sure it lines up. Subtract. This cancels. Minus minus turns to plus. That's 9x. Drop down. All right, now you ask yourself, does x squared go into 9x? So you're saying x squared times what is 9x? No. No. You would have to divide something, and we're not doing that. This is answer. Your slant asymptote is y equals x. You do not care about the remainder. Okay? All right, let's go ahead and get the graph going, by the way. All right, let's put that y-intercept on. So it's over 0 up a ninth, so teeny tiny. There we go. And then we have a slant of y equals x. So it's technically y equals 1 over 1x plus 0, right? So it's going to hit on 0, up 1 over 1, up 1 over 1, down 1, left 1, down 1, left 1. Dash it because it's an asymptote. Okay. All right. I'm going to delete off that long division just for room. So if you need that, rewind the video. Okay, now we want to factor. The top is a difference of cubes. Some teachers do this with the SOAP method. Just do however you've learned. I'm pretty sure I have a video on the SOAP method if you go into my Algebra 2 playlist. Or just type into YouTube SOAP method for cubes. What you want to do is you want to do a small parenthesis and then a larger one. You're going to take the cube root of the first thing. Well, this would just cancel and be x. You're going to take the cube root of the second thing. Cube root of 1 is 1. Okay, and just leave the sign blank there for a second. For the big parentheses, you take this first thing and square it. You multiply these two together, and then you take the back thing and square it. And then it's called SOAP because you leave the sign the same. So see it in the original, it was minus. So you're going to leave it the same. You're going to do the opposite. And then this one's always positive. So again, feel free to Google up SOAP method. I'm pretty sure I have a video on that if you need it. All right, that's the top factorization. And again, that was a difference of cubes. I'm going to kind of just erase some of this now. And then the bottom factorization, that's a difference of squares. This one should feel more comfortable. You set up two parentheses. You take the square root, so that would just be x and x. You take the square root, which would be 3 and 3, and one gets a plus, one gets a minus. Does anything cancel? No. So if you have a spot on your paper that says holes, none. So that's nice. We won't have to worry about that. This time we will have vertical asymptotes because we have a bottom. Set those bottoms equal to 0. So do x plus 3 equals 0, x minus 3 equals 0. Move over, move over. This gives us vertical asymptotes of negative 3 and 3. You do need to have x equals. So on the x, 1, 2, 3, dash, 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 dash. 1, 2, 3, negative 3, dash, 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 dash. Okay. Alrighty. We will have x-intercepts. That's the top set to 0. So x-intercept. So I'm going to set x minus 1 equal to 0. Move over, and that would be 1. Okay, so right there. There's our kiss. And now, should we set the quadratic equal to 0? We should. X squared plus 1x plus 1 equals 0. You could try to factor that. It won't factor. Technically, we should do quadratic formula. So this is A, this is B, this is C. Negative b plus or minus square root b squared minus 4ac AC all over 2A. All right, but the under the radical there, got to come up to the top. I'm in purple. It's -1 plus or minus. That would be 1 minus 4 all over 2. So that's -1 plus or minus root -3 all over 2. This will result in i's. We can't graph i's, or we can, but we're not. Not at this level. That's more of a calculus thing down the line. So this one gives us no x-intercepts, and this one gave us the 1, 0. The purple kiss I've already graphed. Okay, so we technically should check that quadratic, but it doesn't give us anything. So I'm going to take all that purple off that didn't help us. Okay, I think that's about all we can get here. Okay, so that makes it real annoying. Okay, this is going to be, I believe, in 3 parts. And we kind of just have to ride these waves here. And we have to hit the red dot and we have to hit the purple dot. Okay. So see the blue and the pink? I think we're going to make like kind of like a U shape down here, arrows on both sides, riding those waves. And then see the blue and the pink at the top, make kind of another U shape riding those waves. Okay. And then in the middle, we need to hit the red dot and the purple dot. And it usually looks like a snake. But just to be on the safe side, that's 1, that's 2. I'm going to put 2 into the function. So I'm going to do the original function at 2 just to see what it's like. So that would be 2 cubed minus 1. Okay, that's 7 over 2 squared minus 9. So that's -5. So when I put in 2, I got -7/5. So over 2 down 1 and a smidge. Okay, now I'm going to put in -1. So I'm going to do the function at -1. So that's -1 cubed minus 1. So that would be -2. And then -1 squared minus 9. That would be -8. So that's a quarter. Okay. So when we put in -1, we got a quarter. So -1 up a quarter. Okay. Ride this pink line. Snake, snake, ride the pink line. I think that's what we do. And that helped me kind of just get these other 2 dots to kind of see the snake forming there. That's maybe not required, but it helped me. Okay. There we go. It is okay that that snake broke the slant asymptote. It's okay. All right, domain. All x's except the vertical asymptotes. So go -infinity to -3, which is the left pink line, and go between the pink lines, so -3 to 3, and the right pink line, 3 to forever. Range, I think everything, yeah. We didn't have a horizontal asymptote and we didn't have a hole, so I think range is just down forever, up forever. Yeah, I think so. End behavior. Trying to squeeze this in. Oh my goodness. End behavior. Okay. Very right of the screen. See this orange little man? He would walk to the right and I think he'd go up. Yeah? So I would say as x goes to the right, the function goes up. Okay, now very bottom of my screen, little man, orange again, to the left, I think he would go down. As x goes to the left, the function goes down. Okay, that's a lot of work. All right, pause me if you need to. I'm going to take all this off and see if we got it right. Looks pretty good. Let's zoom in. There's our y-intercept. 0.11111 is a ninth, so that's good. There's our x-intercept. We had that. You can see the snake there. And let's put in the asymptotes. So the slant was y equals x. Yep, that looks good. See how the asymptote is kind of cradling the function there? Let's put in our vertical asymptote, x equals 3. Yep, that looks good. And the other one was x equals negative 3. Yeah, it looks good. I think that's fine. So kind of a snake thing in the middle and kind of two U cup things toward the ends. Okay. Alrighty, I'm going on to number 3. All right, we have negative 1 over x squared minus 4. So yeah, cheated again. Went ahead and graphed it. There it is. All right, so let's see if we can get our answers. Sorry about that. To match. Sorry, just dropped my calculator. Hopefully it's alive. Okay, I think it's alive. Thank goodness. All right, number 3 here. Okay, so I'm going to clear this off. Let's see if we can get our arithmetic to match this. Not arithmetic, our algebra, really. That's what this is. Even if you're in pre-calc right now, this is algebra. It's hard algebra, but it's algebra. Okay, so before factoring, we do the y-intercept, plug in 0. So that would be negative 1 over 0 squared minus 4. Negative 1, negative 4, so that's 1/4 because negative negative turns positive. Okay, and then we also want to do the horizontal asymptote with pigs and queens. So horizontal asymptote, this has x to the 0. It's invisible, but it's there. So we have 0 pigs, and right here we have 2 queens. Queens are bigger. If the queens are in charge, they rule fairly, and we will have a horizontal asymptote right through the middle at y equals 0. Let's go ahead and start the graph here. So we can put on that y-intercept of 0/4 and a horizontal asymptote right through the middle. So dash right through the middle horizontally. Okay, now that's the only 2 things I do before factoring. We will not have a slant because again, a slant will only happen if there's one more pig than queen. So if you have a spot for a slant, go ahead and write none. All right, let's factor. The top is fine. It'll just stay negative 1. And the bottom is another difference of squares. So not the soap, but the easier one. Take the square root, that's x and x. Take the square root, that's 2 and 2. One gets a plus, one gets a minus. We will have vertical asymptotes because we have a bottom. So set both of those bottoms equal to 0. So x plus 2 equals 0, x minus 2 equals 0. Move over, x equals 2, x equals negative 2. So 1, 2, dash, 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 1, 2, dash, 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 dash. Okay. For the x-intercept, you do the top equal to 0. Negative 1 equals 0. No, it doesn't. We will have no x-intercept. No holes because nothing canceled. All right, so this is kind of where we're at here. That is not a lot of info. So I would just plug some numbers in. So let's plug in 1 into the original function. So let's do f of 1. So that'd be negative 1 over 1 squared minus 4. So that's negative 1 over negative 3, which is a third. Okay, when we plug in 1, we got a third. So over 1, up a third. So that would be a little higher than the red dot because that was a quarter. Let's put in negative 1. All right, I'm going to just erase the work every time. So pause me if you need to. I'm going to put in negative 1. F of negative 1. So that'd be negative 1 over negative 1 squared minus 4. That'd be negative 1 over negative 3 as well, which is a third. So when we put in negative 1, we got a third. So negative 1, something like that. Okay, that's making me think that this part, you ride the pink line, go, 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 ride the pink line. That's what I'm thinking there. Let me clear for a second just to make sure my thinking's right. I'll put this all right back. Yes. Okay. So I think that's the middle section. So our pink dashes, our vertical asymptotes are at 2. So let's check something beyond 2. So I'm going to plug in 3. So I'm going to do f at 3. So that's going to be -1 over 3 squared minus 4. So that's -1 over 9 minus 4, so 5. So I'm going to the point would be 3 -5th. So over 3, down just a smidge. Okay, that makes me think this part, you ride the pink line, write it, write it, write it, hit, write it, write it, write it. Because see that black asymptote, the horizontal? There we go. Okay, and I'm going to put in -3 because the pink on this side's at -2. So I'm going to do the function at -3. So that'll be -1 over -3 squared minus 4. That'd be -1 over 9 minus 4, which is 5. So -3, -5th. So over 3, down just a smidge. So again, ride that black, ride the pink. There we go. That's the function. That's the graph. Okay, from this, we should be able to get domain. I'm up at the top in black pen. We just need to throw out the pink ones, the vertical asymptotes. So left forever until we get to -3, stop. In between the two asymptotes, so -3, not 3, sorry, these were 2's, -2. And in between the pink dashes, so -2 to 2, and 2 to infinity. So we just basically stopped at the pink dashes, the vertical asymptotes. Range. This definitely goes down forever, and then it goes up to the black dash, which was 0, stop. And then it starts again after the black dash, up forever. So we just threw out the horizontal asymptote. Okay, and finally the end behavior. Let's put a little man on the very far right. There he is in orange. Walk to the right, and he levels off at 0. So as x goes to your right, the function will level at 0. And now I'm going to put an orange little man on the left side, walk him to the left. He will also level off at 0. As x goes to infinity, oh, nope, -infinity, because this is left, the function levels to 0. Okay, that's fine. Looks good. Pause me if you need that one. I'm going on to number 4, which is the last one. Here we go. On the top, we have 3x squared plus x minus 4. And on the bottom, we have 2x squared minus 5x. Ugh, another kind of snake thing in the middle. All right, let's see if we can get our algebra to match that. All right. Oh, sorry, my annotate thing's being silly. Come on, buddy. 1 second. Let me reshare here. My annotating, I dragged my annotate button too far off the side. No, it's still too far off the side. Come on. There we go. Got it. Okay, let's get our algebra to match that graph, hopefully. All right, let's do our y-intercept before we factor. Plug in 0. So this would be gone, this would be gone. We'd have -4. This would be gone, this would be gone. So, uh-oh, -4 divides 0. You can't divide by 0. This would be undefined. So that means we have no y-intercept. We tried, but just won't have one. And now let's do our horizontal asymptote. This degree is 2, so we have 2 pigs, always pigs on top. And this degree is 2, so we have 2 queens. They are equal this time. When they're equal, we will have a horizontal asymptote, so y equals, and you divide the leading coefficients. So it would be 3 divide 2. Just leave it like that. It doesn't go in pretty, that's fine. Okay, let's go ahead and graph that. So horizontal, so y in 3 over 2 is 1.5. So here's 1, here's 2, 1.5. Go ahead, get your horizontal dash. We will not have a slant because again, that only happens when the pig is one more than the queen. So if you have a spot on your paper for slant, go ahead and put none. And now we will factor. All right, on the bottom, GCF is x. That would leave 2x minus 5. That's all we can do on the bottom. And I did that first because it's easier. On the top, we have a trinomial. Do the first times the last, so that's negative 12. Middle number was invisible 1. If you factor differently, by all means, factor differently. I do the magic X. We need to multiply here, add here. What if you had 4, spend 3? Yes. So this would be x plus 4, x minus 3, but wait, when this front number, this a value is not 1, this multiplies cheating, so we have to divide to uncheat. So that gives us factors of x plus 4/3. That's okay, just leave it. And 3 divided 3, so that's x minus 1, and then the bottom's fine. Does anything cancel? No. So that means we will have no holes. So if you have a spot for that, just put none. We will have some vertical asymptotes. That's the bottom set to 0. So this x, just straight up x equals 0. And then this one set to 0. This would move over and be 2x is 5. Divide 2. So x is 5/2. Leave the fraction. So we are going to vertically dash right through the middle at 0. So make this really, let me switch colors. I'm going to make it black. Go really hard here, straight down the middle vertically. And then 5 over 2 is 2.5. So 1, 2, 3, 2.5. Boop, 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 boop. There we go. All right. We will have some x-intercepts this time. That is the top set to 0. So do x plus 4/3 set to 0 and x minus 1 set to 0. This will be negative 4/3 and this will be positive 1. Okay, the 1's easy. Smooch. Negative 4/3 is like negative 1 1/3. So there's negative 1. Go a little bit past that. So there's negative 2. So that's like closer to negative 1. All right, I think that's all we can do at this moment. All right, so I'm thinking this left side, we ride the green, hit the blue, and then ride downward because this is dashed. So I'm thinking that one has to be like that because we had to hit the blue dot. Now, does the middle have to be like that? Let me check the Desmos real fast. I'll put this all back up. Let me make sure I've done that correct. No. Okay, so the middle is not right. Okay, but the other side was fine. But the middle is not. Hmm. Interesting. Okay, so this second black one is at 5/2, so that's like 2.5. So let's plug in 3. Let's plug 3 into the original function just to see what it's like on that side, because we already have the left side done. So let's do f of 3. So that's 3 times 3 squared plus 3 minus 4 all over 2 times 3 squared minus 5 times 3. I'm just going to plug that through the calculator. Okay, the top is 26 And the bottom is 3. So that'd be 26 over 3. Okay, so when we plug in 3, we get 26 over 3. So that's like almost 9 because 27 divided 3 is 9. So we're going to go up over 3, up like almost 9. So, you know, there. So, well, probably not. This one's like this because it's up. It's above the green line. There we go. So, you know, there's like 9 right there. Pretend. Okay, so now it's just the middle that's annoying. Why are we're gonna actually come through that green asymptote, but I don't know why. Okay, so that blue dot is at 1. So let's plug in 2. All right, I'm gonna do f of 2. So again, let's just clear that. I'm doing f of 2. So that's 3 times 2 squared plus 2 minus 4 all over 2 times 2 squared minus 5 times 2. Okay, putting that in the calculator. Top is 10. Bottom is -2. 10 divided -2 is -5. Okay, so when we plug in 2, we get -5. So like down here. And then let's plug in like a half to the left side of 1. Now that's going to be annoying, but we'll just let our calculator do it. So f of a half. So that's 3 times a half, or 0.5 squared, plus a half minus 4 over 2 times a half squared minus 5 times a half. Okay, I'm just going to plug that all through the calculator at one time. Okay. Ooh, I got error. Okay, hold on one second. Okay, I get 1.375. So when we do a half, we get 1.375. So over a half up here. So it doesn't break the thing. Ride the black, ride it, hit the pink, hit the blue, hit the pink. So we do cross that asymptote. That makes it tricky. So the asymptote kind of the green one only applies to like the left thing and the right thing. The middle can break it. Let me take that off for a second. And yeah. Okay, there's all the work if you need it. Oh, we need domain and range. All right, domain. I'm up here in kind of toward the top in blue. All the x's in the world except for the black dashes. Those are our vertical asymptotes. So left forever until 0 and between 0 and 5 halves. Just look down there at the vertical asymptotes. And 5 halves to forever. The range, I think even though we have a horizontal asymptote, we break it though. Give me one second. Does this ever hit? Let's see. Type in the horizontal asymptote. Y equals 3 halves. Does it hit? Looks like it. Right there. Yep. Okay. So range is everything. Even though we have a horizontal asymptote, we hit it. So there's no holes and we hit the asymptote. So it's just down forever, up forever. Okay. And now end behavior, I'm down in like that lavender color toward the very bottom of the screen. Let's put on our little guy, walk to the right. He would level off at the green line. So as x goes to the right, the function goes to that green line, go back to the very beginning. That's our horizontal asymptote, 3 halves. Okay, come over to the left. I'm putting a little purple little man to the left. He would also level off. So as x goes to the left, the function levels at 3 halves, that horizontal asymptote. Ooh, there we go. Pause me if you need any of that. There he is. I'm going to put in there's our horizontal asymptote. So you can see that that one was correct. See how it's guiding the left side and the right. The snake thing in the middle does hit it. We do not have a y-intercept, but we do have an x right there at 1, and right there, that's -4/3. So those are good. Let's put on the x asymptote. So it was x equals 0, vertical asymptote, and x equaled 5/2. Yep, that looks fine. I think that was it. There it is. Looks good. I'll take off the asymptotes now so you can see it in all its glory. There he is. All right, I hope this was helpful and that you're having a great day. Bye bye.